Can you see my screen?
Yes.
Okay.
Yes.
Yes.
What we will be doing today is we'll go through a little bit of theory before we start the practical session. Again, today's session will be 1 hour. I have a hard stop at 11, but we will try and cover bit by bit. I don't believe in rushing and trying to finish everything very quickly. We will take enough time to make sure you all are understanding what we are talking about and what are the technology requirements for different applications. Now,
Great.
to give you a bit more overview around vocabulary, technical vocabulary is also important. When we talk about solutions, IT services, the important engage into a conversation where there are different technology discussions are happening and how much um, interaction you can do. Okay, so let's start with simple web applications. So what is a web application? Most of the people are consuming web applications for different purposes. And when it comes to a further technical discussion, then the technology stacks and applications are developed using different programming languages, which is not we are going to focus on. We are going to focus on the type of applications and how to serve them, how to make them available for consumers. So in simple terms, a web application is a computer program basically, which serves different purposes or functionalities and features, you can say, for different type of businesses, whether it's a banking business or e-commerce or video streaming media, education, government services. So all of those digital services rely on web applications. Okay.
Yeah.
Now, how do consumers consume web applications? So consumers consume those web applications using either their smart devices, their laptops, their desktop computers. But nowadays, most of the consumers are using their smartphones or tablets. Maximum consumption is happening through those devices. So the developers and the application architects needs to design those applications which are lightweight and fit for purpose, right? You can't keep developing a very big application which takes a longer time to deploy, and it is also very what you can say resource hungry processes, or it needs a lot of bandwidth or connectivity to consume. So the concept of lighter microservices has become more common nowadays. What do we need to serve a web application? Like, for example, you have a software engineering team, they have developed application. Now, what do you need to serve that? You need some sort of platform from where you serve those applications so consumers can consume it. So we need a purpose-built infrastructure basically to serve a web application. And that standard infrastructure is basically set up with lots and lots of infrastructure resources. So it has servers, storage systems, networking equipments, cooling systems, electricity, a lot of. And those facilities are usually known as data centers, right? Since the cloud computing has become more common, normal businesses don't have to worry about data centers or setting their own physical servers, storage, and networking, because they can consume those services from a cloud provider. We will not need to worry too much about that because Kubernetes is a cross-platform. No matter where you deploy your Kubernetes platform, whether it is on your own premises, special data centers, or whether they are in cloud from set up by a cloud provider, it doesn't matter. It works throughout different underlying data center services without consumers knowing from where their services are being served. Okay, so 3 takeaway from this slide. What is a web application? How consumers consume those web applications, and to serve those applications, what we need. Okay. Now, when we talk about web applications, there are 2 major type of web applications, right? One is known as a monolithic web application, which is an old method or old way of developing application. So when you think about a monolith application, the word monolith says a single big application or a single computer program which does do a lot of things. For example, a monolithic app, a e-commerce business, has a business logic in it, data processing in it. It might have a user management service, search functionality, different style of categories of products, allowing users to select products and add them to the cart or basket, and then check out for the payment. So about 15, 20 years back, those were the very common software application, web application development methods. But what happens as a part of these tightly coupled applications, the bug fixes, releases takes very long time, because when you are fixing a bug for one particular functionality, then that functionality needs to be tested against other tightly coupled components for the application. And that release cycle becomes longer and it takes a lot of time. It is slow response to market, and it was a bit cumbersome to manage. And then the concept of microservices got evolved, and it became more common for different application developers to follow the pattern for microservices, so that there are benefits, they can take advantage of those benefits. So like, unlike monolithic application, microservices based application has decoupled architecture. So what does I mean to say that? When you are having a monolith application where so many different functionalities and features are tightly integrated in one big program, microservices are designed to decouple those functionalities and features and prepare smaller programs or smaller web applications which are fit for purpose to serve a specific functionality or maybe 1 or 2 functionalities together, instead of serving a lot of functionalities in one program. The advantage of microservices is the development teams can work on different functionalities and independently without worrying about the responses from other applications, because they can decouple it and design a pattern where parallel development can work easily. They don't have to worry about the dependencies on the other programs, because they are just focusing on input and output of those systems. And those systems will be integrated with external message queues and external endpoints. We will look into that bit more as we go forward. So this is a small visual interpretation of monolithic versus microservices. Now on the left-hand side, you are seeing a monolith approach where there were two very popular patterns for the monolithic applications. They were trying to split business logic and user interfaces in 2 different parts. We are just focusing on the left-hand side at the moment. And some of the very old applications were having everything in one big program, like Java application or any other programming languages, where they were developing everything in one big application and then serving it. Now you can see these small blocks which I am trying to present here are, you can think of them as a different functionality. Like the red block is, say for example, user management, say user registration process. user password change policies or user password change functionality, etc. The green block you can think about is, so in terms of e-commerce application, you can think about that like a green box is showing the catalog, product catalogs and listing products when a user logs into the e-commerce portal. And think about this yellow block as a search functionality where user can search about specific categories like sports categories or clothing, and then search for the products within that. And then there is a business logic backing that up. Once the user has selected those functionalities and for their requirement, then they select submit, which will take them to the backend or middleware, where they're like, we don't have to worry too much about how application works, but I'm just trying to give you an overview about those web applications, how they were developed before as a monolith app. So there were two basic architectures. One was like either having everything in one application, or they were just using 3-tier application where front end, middleware, and the back end was part of the application design. However, however, the modern microservices based architecture is slightly different, is shown as per on the diagram on the right hand side. So what you can think of it as is the queue, like those components which are highlighted as queue, are playing a very big role in microservices. Those are known as external message queues. So what happens, for example, these front end orange boxes are representing user login and registration processes, right? So once that is done, it puts up a message in a queue where relevant other application needs to know who is this user, whether he's been a part of our e-commerce platform or he is a new user. Does that user have consumed our services in past, like purchased products from our services or given some feedback to the seller, or trying to ask for a certain type of service products, whether we are going to sell them in future or not. Think about that. So basically, these square boxes on the left-hand side are decoupled and externally running separately, independently to serve the purpose. Okay. So at high level, is everybody understanding what I'm trying to say? Monolith application versus microservice.
Yes, Deacon.
Yes.
Very good. So don't worry too much. It's just an overview. How you have to just make sure you remember monolith application development versus microservices based application development. And the modern architectures and modern approaches are mainly using the microservices based architecture. Okay, so moving on, how these applications are getting deployed to serve the business needs, right? We need to know. Sorry, Satish.
I'm on mute only. Yeah.
I would highly recommend, if you are joining this session on Sundays or Saturdays, make sure you are in an isolated environment and you put your phone on mute. Otherwise, there won't be benefit for you being physically present in front of your computer and not following us. So how these applications are being deployed to serve the business purposes, right? So once the applications are developed, the next step is it getting tested by the software testing teams. And sometimes there are automated testing models, so you don't have to worry about running those tests manually, but they are ready to be deployed in certain environments. So environments are like set of infrastructure segments or infrastructure resources dedicated to a specific purpose. For example, there are development stacks where developers can use those stacks and deploy their services and test it while they are developing. Then there are pre-production environments such as testing environments, and in testing also there are performance testing, unit test. I mean, different type of testing can be done. Functional testing, testing with external dependencies, etc. And then comes a dedicated pre-prod environment where everything is deployed with the newer version of the services. And those are like production graded environments, but they are running a either newer version of the services or the same version of the service with bug fixes or minor tweaks required for the application to function for different scenarios. So at high level, you think about a development environment, pre-production environments, and a production environments. Those are infrastructure segments or dedicated infrastructures, resources provisioned so that our applications can be deployed and then they can consumed by consumers. Okay, so that is a environment in our terms when we talk about Kubernetes platform services. Now, if you are using physical or virtual servers to deploy applications, the management of those servers and support becomes more complicated. So over a period of time, what has happened, organizations have started looking for platforms where they don't have to worry about managing underlying servers. Or there is a dedicated team who will do it, but major of the consumers of that platform are developers, DevOps engineers, GitOps engineers, Kubernetes support engineers, or cloud native engineers. So they don't have to directly worry about provisioning resources for their platform. The resources are provisioned. The major task for those engineers like DevOps, GitOps, cloud native, and Kubernetes engineers are like they are becoming an interface for software development and software testing teams so that they can provision a middle tier of platform for consumers. In this term, the consumers are our developers and software testers, business analysts. So those will become the consumers for the platform where they can deploy applications and test for this logic and functionalities. And they also don't have to worry about directly communicating with those engineers, which are data center engineers who are looking for hardware and other necessary networking and electricity and expansion of the capacity, etc. So in this particular course, we are going to learn about those skills and knowledge, gain knowledge around that middle tier of platform services where we will become a cloud native engineer or a Kubernetes support engineer or DevOps and GitOps style modern skill sets, which are necessary for businesses to fill those gaps, to run their business smoothly without any interruptions. So as I mentioned, servers to deploy applications directly or virtual servers directly, it is very complicated and cost is very high. Also, the management becomes more complicated for those platform resources. But if we use containers, now I'll come to the point in the next slide. What there are like when you develop microservices, the best approach for deploying those microservices is containerized them so that you can easily deploy on multiple platforms, that you can work with any cloud platform or you can have your own custom build platform. So think about a web application, a microservice web application is containerized, a package with a certain configuration so that it can be deployed anywhere. Okay. Now, this is a visual representation of what I was trying to explain in my previous couple of slides. Transformation happened in last 20 years or so. I have worked with all these three major platforms. The transition happened and it started happening around 15 years back, but the virtualization was also very common those days. The containerization has started in last about a decade or so. So I'll just walk you through a little bit on this representation of platforms, how they were built before containerization and after containerization. Okay. So on the leftmost section, you can see this is an old school application deployment on physical servers. So in those days, what was happening when I was a system and network administrator working with different uh, companies, and most of the companies, the common pattern was they were buying servers. Servers are like high-end computers basically, and they were installing them in a special facilities called data centers. Like as I mentioned, there are special facilities where there are data centers where servers are racked and stacked, connectivity is there, electricity, cooling, everything is at a high end. So you don't have to worry about normal issues. And then every company have their own choice of operating system to be installed on those servers, and then they were deploying applications. Those days, most commonly used applications are like Java applications, PHP applications, Perl was another programming language. So those applications were developed and deployed on those servers. The reason they were deployed on the same physical server was because they didn't have much resources, in the sense they cannot buy like 20 servers for different purposes. So they were like sharing a physical server across multiple applications. Now, obviously, when you start doing that, there are dependencies on operating systems. You might be using a laptop or a computer where every now and then you are seeing there is an update available on your operating system, your update available for your system, and you have to update that. Similar to that, on Linux and Unix servers, time to time, you will have updates for different components of your operating system, and you have to update them. And the biggest challenge in those days was when you update something on your server, it has some other further dependencies on small libraries and small other software or engineering software components, which was working fine with one application, but it may affect other application. It may you may start seeing issues with other applications because some of shared, right? So it's a shared operating system. You can say the host operating system is shared across all these A, B, and C. So those times were very critical and difficult. You won't be able to update your system as frequently as you wanted. And then other like engineering approach was evolved, which was known as virtual machines. Now, virtual machines were like very powerful approach for isolating your applications using VM virtual machines, so that on a host operating system, you install another special software, which was known as hypervisor. There was also another software like VMware and other operating systems available, which were like fusing these two hypervisor and operating system model layers, and they were known as type 1 hypervisor or type 0. People used to say that. Don't worry about that. So we have to just focus on this part, like to fix the problem when we were sharing a particular server among multiple applications. The newer approach was developed, which was like 15, 17 years back. This became more common and people were started using that, so that you install a specific OS, a specific dependencies like binaries and libraries and that application. So that in this particular approach, the benefit was you have a choice of dependencies to install and deploy this virtual machine for the type A application or application A. And that will not affect application B because it is completely isolated, and it doesn't have to worry about the binaries and type of applications updated on the first virtual machine. Similar to app C. So like this particular hardware was supporting one operating system which has 3 virtual machines running on it, and those 3 applications can run independently without any problem. The only issue was the cost was very high. As you can see, you are running a full stack operating system, multiple copies of full stack operating system. The time was still, it was taking a bit more time. You needed powerful hardware resources, and then these guest operating systems were like isolating your applications, but you don't need the full guest operating system to run your application, right? In isolation. So recently, last 8 to 10 years, the newer approach is evolved, which is known as containerization, where containers eliminate the layer of guest operating system, because mainly when you develop microservices and applications, they need certain type of dependency. They have certain type of binaries and libraries to be rely on. And most of the OS level components can be easily shared among those applications because they don't rely directly on those OS components heavily. They need a set of services, but mostly when you develop and run the application, it needs certain dependencies. So with this newer approach, the good thing is it is a very cost-effective approach compared to the previous two approaches. It is very quick to develop and deliver your services. You can say the bug fixes are quicker, you can test it quickly, you can release it quickly. So the time to market for your applications and business needs are very fast. And that is a very big winner. In last 10 years, I have seen lots and lots of development has shifted towards containerized development. And a lot of businesses have adopted and welcomed this approach because it is giving them immediate boost in time to market. Development is quicker, fixes are quicker, they can release new features and functionality quicker. And the most important thing is they can quickly hire new developers when there is a need for developing new features and functionality, and they can develop it independently without worrying about a tightly integrated model. So old school physical servers, the not very old, but 10 years back, everything was running on virtual machine, and still it is not transitioned yet. There is a lot of movement happening in industries where now people are moving from virtual machines to containerization. The concept has been rock solid now. People have adopted it, and new ways of building and deploying services is happening. Any questions so far?
Sorry, Nilesh.
Yeah.
Nilesh. Can you generate any kind of general example regarding this table? Like, because I'm IT level, I can get it a bit hard to understand this. Like, but if you can generate kind of like general example, so I can get in my mind about this.
Yeah. So if you have not understood this, I'll try to explain it again. Okay.
No, it's not like I'm not understood. It's like I'm getting a little bit hard to understand, but like something like if you can give general example for this,
So
which can give me
which
more better idea, like yes, how it works.
bit you didn't understand?
No, like let's say like this virtual machine, okay?
Uh,
You saying like application A, like there is a binoculars and libraries, and there is a system like guest OS. So in containerized, like the guest OS is like come up from there. So what happened there, like with that guest OS, like how it worked is not in that containerized.
yeah. So in that case, what I was trying to say that the guest OS operating, the older approach for guest OS was to isolate the application A from the host, right?
Mm-hmm.
Now, eventually, when you develop a microservice, you only need these binaries and libraries. And
Mm-hmm.
when this virtual machine approach was designed, the
Mm-hmm.
container engine was not present. It was not developed. It didn't existed.
Okay.
So from the leftmost uh, uh, from the leftmost approach, you can see there was a problem where we are sharing the operating system. So the virtual machine concept came in play where you have a isolated guest OS. Guest OS means think about a Linux server running in isolation on a hypervisor.
Mm-hmm.
So you are running three Linux servers here. App A has its own server, App B has its own server, App C has its own server.
Okay.
Now, this particular approach was to solve immediate problem of sharing the operating system for applications because there are different dependencies and different versions of binaries which needed run. This was the older concept. Now, when companies like Docker came up, which we will see, the containerized approach we will see in more detail, and that time it will be more clear. But to answer your question,
Okay.
the in industry, the open source community is so big. When they see a problem, there are different individuals who start developing certain solutions to fix problems or to build a better solution. Okay. So when the virtual machine concept was evolved and it was very common, some individuals did started thinking about saying that this guest OS is very common and we don't need that for all of these applications. Because newer style of microservices just need certain libraries and binaries to run that application. So then instead of hypervisor, a container engine was evolved, which is a special software which manages these things and eliminates the requirement of guest OS.
All right. Okay. So it's a special software. You mean you try to?
Yeah.
Okay.
Yeah, which allows you to run your microservices very easily. Yeah.
Okay.
Okay.
Okay. Getting you. Yeah. Thanks.
You're welcome. So what is containerization now? How this concept was evolved and how it common for the purpose of building and running services. You think about, I'll give you an example, and this is how it was evolved. Okay, we all know that goods are shipped across the globe from different origin and destinations. Now, on the left-hand side, the left picture is showing up the cargo pre-1960s, the cargo system, which was shipping goods across the globe, right? When there is a demand, like Indian spices were shipped across different countries and woolen clothes were shipped across different countries, dry fruits, different engineering tools. So think about a cargo system pre-1960 was like this. It was shipping goods, but different shape and size of goods were packaged differently. And um, uh, the industry was running, but it needed a better approach to streamline those operations for cargo shipping. Yeah. And then the new modern cargo system was evolved, where what they did is they started sizing up containers of small, medium, large size. And instead of shipping goods for one origin from one origin to another, they were like sophisticatedly tagging and packaging them in a container, so that the container is going from A to B destination, from A to B, which will be having the goods going towards the same destination, so that they don't have to worry about managing, and micromanagement happens. It doesn't require. So you can clearly see the cargo system pre-1960 was working, too much organized, whereas the modern cargo system is very well organized, and shipping industry is able to ship goods across this cargo system very efficiently. The takeaway from this slide is, think about the monolith applications as pre-1960 cargo system, which was like there is a small application, you still need to deploy it on a server without any isolation. Where the modern way of doing, when we go through containerization, then it has a special process, a method, which allows it to be deployed anywhere on the Kubernetes platforms or container platforms, containerized container orchestration systems, anywhere on any platform. We will learn into more detail, but this is like a non-technical example just to get a bit more understanding. Like the modern microservices-based containerized application is a very sophisticated way of building and shipping your application, or building and deploying your applications, so that it's easy to track those applications, easy to build and fix features and functionalities, and it's very quicker. Right? So containerization in terms of computer applications. So based on the slide we saw earlier with the physical servers, virtual servers, and containers, containerization is also one type of virtualization, but it is at the isolation and OS level. You don't need to deploy multiple operating system, multiple servers with full operating system. It eliminates that layer, but it has a sophisticated program called container orchestration system, which has a special driver, container runtime interface, which allows you to deploy your application in containers. Containerization allows us to bundle applications with software binaries, as we saw earlier. And the slogan is build once and deploy anywhere or run anywhere. So like you don't have to worry if it is a Google Cloud, then you don't have to build it specially. If it is a Azure, Microsoft Cloud, you don't have to do anything special. If it is Amazon or Oracle or Red Hat, IBM, all of those container orchestration platforms will be able to allow you deploy your applications easily. So um, the biggest advantage is your developers and software testers have done a good job. They have developed and built a service. Now, tomorrow, if you want to deploy on a cloud provider's platform, or you want to build your own platform, you can deploy Kubernetes on your own data centers and then deploy your applications. You don't need to re-engineer those applications again and again when the platform changes, So that is one of the biggest advantage of containerized application, which solves the problem of complexity. Where in old days, even if the virtualization is changed, even if the base operating system has changed, there were a lot of things you had to change. Even if it was a Java program or a PHP program, when you try to run it differently on a different platform, it was showing up issues because the underlying dependencies were different. Containerization is streamlining that particular uh, layer of dependencies, and you can build once and deploy anywhere. So containers do not require hypervisor because it has a special runtime interface, which is known as container runtime interface. As the Docker is one of the most popular one, but from the open source point of view, the container runtime interface is CRI-O open standards. I will share the website for that. You can have a bit more read about it. And we will consume these particular runtime interfaces more and more as we progress in this course. Docker is most popular because they started it early. They are the first one. The Docker Desktop is a free open source, free software for individuals. But if you are a big company and if you have certain number of employees, then you have to buy the license. For the training purposes on this course, it is completely free because you are the only one and using that for learning purposes. And you can see, I'll show you a bit more details, but this was the slide we prepared back in 2020. And this is the graph of adoption for the container orchestration systems. And Kubernetes is one of the most popular. The whole graph shows about Kubernetes from 2015 up to 2020. It became like nearly a very popular operating system, very popular container orchestration system, sorry. And this slide shows you about the last few years of the adoption from 2020 to 2024. You can still see it is at the top, the 100% big mark. So these are the releases where new systems are coming in play and old systems are going out. But you can see it hasn't dropped from top up to 100%, 80 to 100%, as this is the most popular container orchestration system. In the below graph, I am showing you it from since 2016, 1st December 2016 up to now. You can see there is a steady, sharp, exponential growth for Kubernetes, and it is still growing. You can also search about these trends on internet. It has become more popular and more common now everywhere. Kubernetes is a de facto standard for building and running your applications, whether it is a government project, public sector, private sector, education. Everywhere you will see that Kubernetes has become a more has been adopted more and more for running and building applications. Now, so that was a bit of a theory about what we are going to learn in this course. Based on last week's session, is there any other question anyone have? Did you all practice what we learned?
We have I have downloaded that the three things you told: Visual Studio Code, Git Bash, and Docker Desktop. It is on my laptop now. Yeah.
Okay, good. So what I will what we will do today is, last week we did some work with the terminal directly. Now today we will integrate this terminal into our Git bash, because it is necessary for us to work with our terminal. Okay, so if you remember, this terminal, those users who are using Windows operating system are having Git bash. So now I want you all to open up Visual Studio Code on your system. So when you start the Visual Studio Code, you will see something like this on your system. Does it show up like this?
Yes.
Okay. It may have a small window in the center saying open a folder or create a folder, something like that. Okay.
Yeah.
So you can click on open a folder and open up the test training folder we created last time. Okay.
Sorry, I was not having that last time. If you can show me how to create that folder.
Well, I did share those slides
You
with.
said, okay, I open the folder, and like you want me to find out the training folder, yeah?
Yeah, which we created last time.
Okay. Okay, no, I was in a different computer that time. That's why.
Oh, okay. So you can also create a new folder using this button, but yeah, you can click. Once you explore this, you will see a new folder. You can also create a new folder basically, and then open it from here. Everybody else is following us?
Well, can okay, so I just need to open in the new folder. Okay, new. Okay, which is called training. Yeah. Okay, I have opened that folder training.
And now, is everybody else following us?
Yes, we can.
Yes.
Okay, good. So what we are going to do now, we will be integrating this terminal to be accessible from our Visual Studio Code. So last time what we did, we created a training folder and then created a test01 folder just to see in the permissions on that. Now all of you will see let me just share this again so I can share the whole screen. So now you can see this when you click on Visual Studio Code, there is a option on the top bar. You will see different options like terminal, run, view. Can you see the view? And then there is a terminal again inside the view menu. And when you click on that, you will see a small terminal window popped up on your Visual Studio Code. Do you see that?
No, Microsoft is in
Yes.
a different maybe.
Okay, you might have a different menu then, yeah. So you may need to find out yourself in your Microsoft Visual Studio Code how it is appearing, but you should be able to bring the terminal there. And then there is a small option here, a drop down option, from where you have to select Git bash. For me, or for all the Mac users or Windows Linux user, it will be bash. And then in your case, do you see the Git bash option there?
We can see the bash in Windows.
Git, it may be Git bash probably, or bash. You should be able to see a Git bash as well.
We have both the options, Git bash also.
Okay. So now, what we are going shell script for us. So in my case, I have a lot.
No. Nilesh, your voice is breaking a lot. Could not hear.
We are not able to hear you.
Can you hear me now?
Yeah.
Yeah. Okay. Sorry, my I think there was a bleep in the connection. Okay. So what I'm trying to say is you might not able to see all these files because these are my files, but you should at least see a training folder from there, and then you have test01 folder. Okay.
Yes, correct.
Yeah, we can see.
Now you can create a new file like on this. When you highlight your cursor there, you will see a file option, a folder option, and these options again. So you can click on file while selecting either a training folder or a test01 folder. You click on that and say test1 file and enter. And it will create a test file there. Something like that, which you can follow.
Yes, I got that.
Right. And now just type something like this is a test file. And then save this file. Yeah. In my case, I'm using command save, or you might have Control S, or you will be able to save it from other ways. There are different ways to save your file on your system, right? Now, once you have saved the file, on the terminal window beneath, like there is a separate window, you can go inside the folder where you have created the file, and you can type ls-l to see and double check the file is created successfully and the owner and the permissions are there.
All right, we can see.
Okay, good.
What should we type there? Test01.
Looks like you haven't done a reason for the content we covered last week.
Mhm.
If you are new, that is fine. But the point is, if you are new, then you need to revise the content from the previous session,
Okay.
which will, otherwise, what will happen? You will keep getting confused.
All right.
Are you following? So what we did, we just created a file with some simple text in it.
Yeah, I have in a Visual Code, I have created that folder training, and in that
Okay.
test one, this is a test file. I save that,
Okay.
and then like I'm not getting like this one, the terminal. What you're doing?
So if you can, does anybody else wants to help him on the call? How to attach this terminal?
No, I'll try myself with your, if you can share me your previous sessions recording. I'll get myself up to here, and then if anything I need, I'll call you, or like I'll get help from others.
So quickly, I can tell. No, I was just asking someone else if they have the Windows system, they can show you immediately.
Yes,
But
yes.
Huh?
Yes, yes. You just go on view option in Visual Studio Code,
Okay, one second. View option. Okay.
and then there is a last option like terminal. You just click on that,
Okay. Yeah, I have.
and then terminal you can open the small slide. You can click on the plus button, launch or something on the right hand side top.
On the right side. What's that button called?
A PowerShell, Git base, command prompt,
Yeah.
Java.
Yeah. PowerShell button is there.
Yeah, you just go on Git bash.
In PowerShell, I go to.
Select Git
No,
bash.
Git bash, Git bash.
Like here. Do you want to share your screen, Keyur?
Yeah, just a second.
Wait, I need to make Keyur co-host. Yeah, Keyur, now you can share the screen.
Yeah.
Okay, if you can show me, I am up to the PowerShell, but I can't see the Git bash anywhere in there.
No,
Okay.
Did you install Git bash last time? Or because you were on a MacBook, right? Last
No,
time?
I have Git bash installed in this.
no, you found terminal now and click on three dots.
Here.
Click on three dots and select Git bash.
Okay, when I click on three dot, it says clear terminal, scroll to next command, scroll to previous command, run archive file, run select text. I'm doing this in Visual Studio Code, yeah? All this?
You.
Wait, I send on group.
Okay, let's do one thing. I will share the slides from today's session on the WhatsApp group. Okay.
Mhm.
Okay.
And all of you can just get up to this level where the training folder is there, test0 or whatever folder you want to keep track of this. And the next thing was you add some text content to the file, and we will grep example grep test, grep command test and test1. So which is trying to find out there is one line with the content. So I was just trying to be more interactive. Last week we were just using the normal terminal like text black and white terminal. We want to start using the Visual Studio Code and terminal together so that we can start into our work cycle. This will be our local development environment, and then
All
we
right.
and next week, make sure everybody has, so everybody has the Docker desktop installed now, right? On their computer?
Yes, yes.
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 Okay, perfect. So I'll give you a couple of small tasks, like what you need to do now is, sorry, Sanjay, I think somebody will.
No, that's fine, but I found that Git bash option and I'm
Perfect.
onto it now.
Perfect. No
Yeah.
worries. So what we need to do is now, before next session, you all need to go to hub.docker.com. And when hub.docker.com, you will be able to sign up for free. just if you want to do it now, you can you see my screen right now? That's a difference.
Yeah, yeah.
Yes.
So you are seeing the hub.docker.com screen, right?
Yes, we can see.
Okay. So you can do sign up. I'm already signed up, so I'll use my login. And so once you log in, you will have blank screen. I have created registries, so I'm seeing my repositories. But you should have your name here, like coming up here, and you will be able to log in successfully. When you sign up for the first time, it will send you an email for verification. So make sure you use your correct email address. And once you have that account, you will be able to log in your Docker desktop using that account as well. So make sure you have this sorted, and we will take it forward from there next week. Yeah.
Yes.
Yes.
Creating a login and then sign in with that credential on your system. Okay. Advanced sign in. Okay, so I was already signed in, so I can see my login is there. Okay, so we will start with a little bit of bash scripting and concept about containers locally from next week. Okay.
Yes.
Yeah.
Right. Take care. Have a nice.
Thank you.
Thank you. Bye-bye. Take care.
Thank
Bye-bye.
you. Thank you.